Hey guys. So today the plan is to do the Edu round, and then I think you voted on the ARC, which is actually going on right now, but what it means is that once I finish the Edu, the ARC will be also finished and we'll be able to do that. So yeah, let's start with this. So I can give out the link. With this. Yeah, this. Hate you guys so much. Okay, so wait, let me mess with some stuff. And okay. We'll start by updating the sub count. I actually forgot to do that during the bubble cup, which I'm sad about, but I can do it now, so I guess that's fine. Yeah. Let's do that. And the template. Alright, let me get set up on mobile, because I gotta like be weird like that. For some reason it doesn't show up. I'm streaming, right? Why am I not? Can't get my own setup. Alright, that's weird. Let me do that from here. Okay. Yeah, that's what we're doing. So I'll leave that. Yeah, we're doing the ARC. Just ARC level. And that will be right after this. So we're going to start with the Edu round because that's done. I can't do the ARC right now. So we'll do a virtual in something like 2 minutes, I don't know. And then everything else is set up and close all this stuff. Say my name, please. What's up, Crystal Violet? How are you doing? Why would I start from C? A and B are easy. I'll just like mow through them and then they'll be like 2 minutes. Well, yeah, but if they're easy, I'll just like finish them in 2 minutes and then we'll be done with them. I'm not gonna do it backwards. Edu rounds are too hard for me for that. Yeah, they're too hard. Okay, we begin. Let's do this. Okay, there's a difference between boring and annoying. If it's just boring, then we can finish it quickly. And if it's annoying, then that may be a problem, but hopefully not too much of a problem. According to this new layout, the building consists of 3 types of apartments. 3, 5, and 7 room. Each room has exactly 1 window. Okay, so for here, let's read in the thing. I don't know why this saved, but okay. So think about it like this. Well, if a number is small, like if a number is small, like let's just list out all of the small numbers. Like these two are obviously impossible because we need 2 and 3 rooms. This is impossible because there's nothing we can do to get it. Everything else can be represented as some combination of 3s, 5s, and 7s. Specifically, 5 and 7 are different mod 3. 5 is 2 mod 3 and 7 is 1 mod 3, which means that the way to like go with this is, so it's a number like 12. Either it's divisible by 3 already, which this, or let's take like 3 consecutive numbers. So in this case, it's already divisible by 3. In this case, we can subtract 5 and it'll be divisible by 3 because this is also equal to 2 mod 3. And this one is equal to 1 mod 3, which means we could subtract 7 and have it be mod 3. So basically, we only have to check for the special cases and everything else is kind of simple. So if n is less than 3 or n is equal to 4, else if n mod 3 is equal to 0, n minus 5 mod 3 is equal to 0, one. Otherwise, implicitly, n minus 7 is divisible by 3. That should work. 1000, we can use like any number, right? 1000, 2001, 310, looks right. See, that was 3 minutes. It's not that bad. But okay, now you have n barrels lined up in a row. The ith barrel contains AI. You can pour water from one barrel to another. And in one act of pouring, you can choose 2 different ones, X and Y, and put the stuff in there, any amount. Max, oh boy, you can pour at most k times. Maximum possible difference between the maximum and the minimum. Okay, let's have ideas for this. Just read the input. And we can sort it because we can do whatever. Then I guess here's the idea that oh, it's the maximum possible difference. I see. Not the minimum. Okay. So if you sort it, you're gonna have some like stuff somewhere. And so k is 1 at least, which means that say you have some stuff like this, 2, 3, 5, 7. Some nice prime numbers, and 13. Right, so like this is already the maximum, so we might as well just like keep it the maximum. And then we want to pour some of this stuff into this so that we maximize the difference between the maximum and the minimum. And well, in one pour, we can make the minimum 0. So now we just want to make the maximum as big as possible. And the best way to do that is to just go through pour like the biggest ones possible into the one that we're trying to make huge. This is equivalent to taking the first k plus 1 barrels. Oh my god. Cannot type. That's what it is, right? Yeah. You can take the first k plus 1 barrels. 10, 0. Let's try one more. 1, 17. Nope, not n equals 17. No. 1, 3, 5. Oh wait. 2, 1, 3. We do sort, right? Yeah. And then we can take 5, 7, and 15 and put them all into 15, and then we'll be good. Alright, now we're on C. You happy? One operation, you can erase any two numbers a and b and write one integer a and b. A plus b over 2 rounded up. Okay. So I assume we want to minimize the number of round-up operations, because every round-up will like give us some problems, right? Yeah. So if we do like 2 evens and 2 odds together, then if we do 2 evens together or 2 odds together, then it won't round up. Oh, we have, okay, n is like fixed. I mean, the numbers are 1 to n. Okay. Does that help? Probably. I mean, it's better than working with arbitrary input. So the question is, can we make everything the same? Can we make every operation we do use numbers with the same parity? Because that's ideal. Because every operation we do in the numbers aren't the same parity, means that we're going to have some we're going to get a bigger number, and we don't want to do that. So let's see. Say that what? Let's just write out some values of n. Let's say 1, 2, 3, 4, 5, 6. Okay, so we begin. Let's start by just doing what the sample tells us to. We merge these 2 into 5. Then we do this again, and we merge these 2 into 5 again. So now, with this terrible illustration, we have 1, 2, 3, and 5 left. Now, we do 3 and 5. I'm going to make this easier for you. Okay, so that just happens to work here. It doesn't mean it's going to work everywhere else. So for this even stuff going on, we can just do that. Let's try some more small cases, because why not? So here we do this. We merge these to 7. We merge these to 7. So now out of these three, we get a single 7. So now we have a 7 here. So we can merge this to 6. And then we merge this to 5, and then we merge this to 4, and then we merge this to 3. Interesting. Huh. So every time we start with kind of this suffix, and then every time we can go backwards and just like keep on going. Keep on keeping on. That just work? I feel like that seems seems like it just works. Just try 1 to 7. Does it work the same way here? So what's like the mathematical basis behind this? Here we can get 6, and then we can merge these two 6s and get another 6, and then we have this, and then we have 5, and then we have this, and then we have 4, and then 3, and then 2. Alright, so like what happens here? So we begin by taking n and n minus 2, which are obviously the same parity. Then we get n minus 1. So then we take the actual value of n minus 1, we merge them together, and then we get n minus 1 again. So now we merge n minus 1 with n minus 3, and we get n minus 2. Then we merge n minus 2 with n minus 4, and we get n minus 3, and so on. And this is all going to be the same parity. So I guess with that's the strategy. We can start by... I guess we can also do it forwards. There's no reason we wouldn't be able to. Like we can do 1 and then 3, merge them to 2, then merge 2 with 2, and then we get 2 again. Then merge 2 with 4, we get 3, merge 3 with 5, we get 6, no, 4, 4 with 6, we get 5, and so on. So basically, of the first 3 numbers, we first make this match, then we get this number, then we get this match, and then we get this number again, and then we keep on like making these matches successfully. Yeah. The only problem is when we don't have 3 numbers to begin with, and that's n equals 2, then we're just kind of like, whatever. Yeah, but otherwise we can like do it optimally. So 1, 3, and then we merge 2 and 2. Then 4, I equals 4, I is less than or equal to n, I plus plus. Okay, and that basically symbolizes this idea. Because we're always going to have I minus 2 and be able to compare it with I. And then we'll get I minus 1, and then we, just keep going. So 1, 3, 2, 2, 2, 4. What is this? 2. 1. No. Let's just do some cases. Okay. 1, 2. Yep. 1, 3, 2, 2. 1, 3, 2, 2, 2, 4. 1, 3, 2, 2, 2, 4, 3, 5. And we just keep on going. Perfect. What? Is this not right? What have I done? Oh, I have to print the number. Oh, okay. Oh, I did not see that. Wait, does doing this make it smaller? It shouldn't, right? Wait, does going backwards make it better? Maybe we do want to go backwards. Oh, wait, going backwards does make it better. Whoops. Okay, going backwards makes it better because we divide the larger numbers more and more, which means that we get like better answers, I think. I think that's how it works. So yeah, we do actually want to go backwards, which is my bad. Let's see. So it's n minus 2, n, that's one operation, and then we print n minus 1 twice. So I think the interesting thing is the answer is actually always 2, because we can just kind of like do this sort of, telescoping thing like this, which is interesting. So the answer is always 2. So this should be I equals n minus 3. I is greater than or equal to 1, I minus minus. And then we say print I, and then the other number we have is I plus 2, which means we can just do that. I'm actually glad that I'm glad that we got caught on the sample, because otherwise we would have a dumb penalty from this. I didn't realize you had to actually print the answer, and I didn't anyway. What am I doing? Jesus. Yeah. Yay, hard coding. Don't you love this? This is so fun. Okay, so let's do some mad cases again. 2, 3, 4, 5, 9. 2, 1, 2. 2, 1, 3, 2, 2. Yeah, we always end up with 1, 3. Okay. And 2 is the best answer because we can't, can we have 1? I don't think we can. There's no sequence of numbers that are bigger than 1 that will let you get 1, because we always have to round up. So I think the best answer is always going to be 2. And we have it. Okay. That was like slow. But whatever. Not really a big deal. Not going for place here. Are any hacks possible for C? Or, oh, for first question. Wait, what was A? That was the one with the, right, that. I mean, the thing is n is small, so I think brute force would actually, like, it might pass. I don't know. How would I prove my solution? Okay, well, here. So the answer has to be 2. Like, the best answer has to be 2. Because it can't be 1. Like, say you have 1. Like, so if it's going to be 1, you have to use 1 in the final operation. Which means of all of these other numbers, you have to also get 1. But, like, how would you do that? All of these numbers are bigger than 1, and the combine operation is taking the ceiling of their average. So, like, no matter what you do with these numbers, you're going to have some number that's greater than or equal to 2 here. And that's a problem because, like, when you merge these, it's also the ceiling, so this number is going to be greater than or equal to 2. So the answer has to be at least 2. And then we can show that the answer can always be 2 by just doing this construction. This construction is always going to work and end up being 2 because you can kind of just, like, do out the numbers. You merge n and n minus 2 to get n minus 1. You merge the two n minus 1s to get n minus 1 again. Then you merge everything with itself minus 2. So you merge n minus 1 with n minus 3. Then you get n minus 2. You merge that with n minus 4. You get n minus 3. Then you merge that with n minus 5. You get n minus 4. And all this happens until you get to the point where n minus 2 is equal to 0. Which means that, no wait, what is it? It's n minus, like, you have some n minus k, right? This is your current number. Then you have that n minus k minus 2 is equal to 0. That's the point where you stop. And so, like, so obviously n minus k is equal to 2. Actually, no. The last merge you can make is when this is equal to 1, which means that n minus k is equal to 3, and then that means you have a 3 here, you can merge it with 1, and you get 2. So yeah, that's kind of the, I mean, it's not a formal proof, but it's like basically just fleshed out why that is optimal. Okay, for D, You have a string, love strings. Can perform operations on this string. Who knew? Select an integer I from 1 to the length of the string, then delete that. Okay, so delete a character. The string S is not empty. Delete the maximum length. Assume you want to empty the string. Yeah. Maximum length prefix consisting of the same characters. Each of, oh, they're mandatory. Okay. Each of the steps are mandatory. Interesting. Why did this get deleted? Was that something I did, or is that just you? Okay, this is weird. Why is it mandatory? Okay, they do give n, which is different from last round. Wait, what's happening? Why are messages being deleted? Okay. Yeah, that shouldn't happen. I'm not doing that. I mean, I'm not trying to make that happen. Okay, cool. Because I remember seeing something else for like the messages that I removed before, but I don't want that to happen. Or like seeing something like that. Okay, why are all the rest of these samples small? You want to max? Okay. This is like putting twists on these problems because you want to maximize the operations. Isn't this just kind of doing it? Like, it wants me specifically to hack his G or just other people? I haven't even read G yet. How does he know I can hack anything? Okay, so here's the first thing. Like, we want these operations to do as little as possible. Specifically, we want to try and waste operations. So let's think about this string, like 11101110. Okay, so here, interesting. All right, so we can't waste the prefix operation. Like, it has to do something. But what we can do is we can make it so the like delete a character operation does as little as possible. Right? So consider this. All of these 3 characters are going to be deleted by the prefix operation. So if we do the single character operation on something in this prefix, then it's basically wasting it. And that's like good because we don't want to delete other characters that we... Yes, this is D. We don't want to delete other characters that like might give us trouble. Right? So how do you check all the test cases at once? Well, it just like I have a template that just makes it so it calls a solve function for every test case. But I mean, you can just kind of do anything. Like a lot of people use like they have some number t and then they do something like while t minus minus and then input what? Solve problem. And then that'll be the structure of a program you can use. Because that like lets you iterate through all test cases and solve them independent of each other. Okay, but so we want to delete characters in like a prefix. But say we have this, right? So if we delete this one, then with the prefix operation, we're going to delete this one too. And then we're going to have this string. But, so that means, I'll take 3 operations, I guess. But if we delete this one instead, like if we delete something from another consecutive group of characters, then we'll delete this one with deletion operation, and it actually still takes 3 operations. But okay, thinking about some other example, like for let's say move the 0 all the way out here. I'm gonna just draw a lot of 1s, right? So say we use the single character operation to delete this one. Then we use the prefix operation to delete this one, like we're forced to. And then we can use the single character operation however we want. Say we just do it smartly here. But then this prefix operation is going to get rid of like all of this, right? So what that means is instead of deleting this character, we could have deleted one of these because it was going to be deleted anyway. So there's no reason to not delete something in that group. And so with this prefix operation, we'll do that, and then we have to delete one of these, and we'll be done in 3 operations. But if we instead do the thing I'm talking about, like we have this whole group here, so we might as well like try and just kill all of these, or waste our moves on this group. So we do the single character operation with this, we do the prefix operation here, we do another single character here, we do the prefix here, and then we do another single character here, for example. Then we could do this, and then we're forced to do it in 4 operations. So basically the idea is for every group that's of size like greater than 1, you just kind of do whatever. Yeah, so this is my idea then. So to kind of implement this, I think the best way to do it is to use some 2-pointer strategy. Break these into groups. Say like this is a group of 1, 1. This is a group of 1, 0. This is a group of 9 1s. This is a group of 1, 0. And this is a group of 1, 1. And then what we can do is we can iterate through this, and with any group with size greater than 0, we can just kind of do whatever we want with it. Yeah, okay. So let's do that. Okay, and actually we don't care about the letter or the value of each group, because we know that if 2 numbers are in different groups but consecutive, then they have different values, which means that all we need to know is that the groups exist. So let's figure out how to do this. Point equals 0. Yeah. So if Si is not equal to S point, then we start a new group, which means that I minus point equals I. And then this is the start of that new group. What the hell did I just do? Okay, good, didn't delete anything. So here's the basic idea of how that 2-pointer is going to work. It's like, so we start with some pointer here, and then we start with another pointer here. And then because the locations of these 2 pointers are different, then what if after deleting elements from the group it reduces to size 1? Well then, I mean it's still wasting a move. Like there's no reason to not reduce it to size 1. If you instead reduce it to size 2, you can still waste another operation. Because at some point the prefix operation will take care of that whole thing at once anyway. So it's like good enough to waste as many moves as you can. That's what I'm thinking. Is that not optimal? I'm not really sure. But I mean, anyway, in terms of implementation, so these two are different, which means that the end of this group is right before this pointer. So then we move this pointer kind of to here, because now this is the start of the new group. Then we go here. This is also a different one, which means that we have a new group at the end of this pointer. And now this new group starts over here. And then we check here. These two are this. Whoa. We start here. These two are the same, which means they're in the same group. So we move this over again. Now these two are in different groups. So we have another group that ends here. And then this pointer reaches the end of the array. Oh, wait. And this pointer gets moved here. And so we have another group that ends here, because we have to like include the last one. So that's why I do this extra step at the end. Let's just make sure that worked. Even though the implementation seems fine, I'm just going to like safety check, sanity check. So 3111, 112, 1111, perfect. So now we, yeah, proof by lack of counterexample. I don't know how to prove it. It's just like, it just seems right, you know? I mean, okay, like at what point would you stop other than 1? Like intuitively, why would you leave it at size 2? Because if you leave it at size 2 and you go like kill some other thing, then like it's a move you could have wasted but didn't. And you want to maximize the number of moves you make, so you want to waste as many as possible. C error to debug instead of C out. I don't know. It's probably a good practice. I'm just like used to C out. Does my terminal even capture C error? I guess it does, but I don't really see the difference. Because I get rid of debug prints anyway. This isn't it, right? Okay. 4. No, this should be at this point we can treat n as the number of groups we have, so we'll just like reset this. Yeah, I know it doesn't look at C error, but I mean, look, it's not a good practice to have debug prints anyway, because output is expensive, and so it's better to just get in the habit of commenting it out anyway. Because like at some point you could like output some huge thing for some huge I don't know, something, and then forget to comment it out, and then you'll get TLE or something because you're printing way too much. I feel like it's better to get wrong answer on a sample because of debug prints than to get TLE on some huge case that you don't even know about. And especially in problems where you're suspicious about the time limit anyway, you wouldn't know if it's the debug output or if it's your actual program that's causing the TLE. So I just don't recommend that. Obviously, we're still streaming. Why am I even checking? Okay. So how's this going to work? Well, we basically want to say, is there anything we can waste? While point I plus point. This is the end because we're gonna have to delete group I from the prefix. And what did I just do? So while point is less than n, if groups I is greater than 1, minus minus groups, that should be point, not I. Then we can break because we've wasted this move successfully. What was the meme? We've failed successfully, or task failed successfully. Yeah, and then plus plus point because otherwise we have to like go on to another group. And because we're doing like the prefix stuff like from the front, we want to waste as many moves from the front groups as we can before we move on to the later ones. And then this is so if point is equal to n, then plus plus I think. Yeah. Wait, how do half operations work? If you can do this, but then this makes the string empty, does that mean that this operation doesn't count because you don't do this one? Is there a clarification on that, or no? I guess we can look at the samples. So how does this work? So we have O10. Okay, so it is, we do count half operations. Okay. That's cool then. Yeah, I mean, okay. It's fine if you're late because the stream will be uploaded. The stream will be uploaded anyway, so you're not really missing out on anything. I kind of knew there would be conflict with the ARC right now, but like, whatever. And then we increment the answer. I feel like this works. Woohoo, proof by lack of counterexample. Let's just make sure this is right. We got the groups, we do the groups, we put the groups in the vector, and we take the vector and we like treat it like an array, and then we do 2 pointers, kind of like 1 pointer, 2 pointers, whatever. While this is less than n, if we can waste the move, we do it, otherwise we have to go on to the next one, and then if it's n, then we can just like, we don't have anything to waste, so we have to go forward, and then we increment the pointer, and while point is less than I plus plus point, I think that's, no, that's fine. Yeah, we can do that. Think that works? E is another string problem. Interesting. Okay, we have D. Cool. Let's go for E. Yeah, I'm doing the ARC after this, by the way, so stay tuned. Which part of the idea? I can do all of it if you want. 2 pointers to make the groups happen, and 2 pointers to count the answer. Actually, I've already gone over the... Wait, which do you want to see? I can kind of illustrate this again, because I have the full animation now. Right, so... we're basically using this green pointer to signify the new groups, and... yeah, this is the full animation. It's so cool, isn't it? It's like a PowerPoint. Okay, yeah. Alright, so say we have, yeah, sure. Let's get some big string, like 1, 1, 0, 1, 1, 0, 0, 0, 0, 1, 1. Wait, actually. Let's make this a very, very big sample. Right? Okay. Now all of these are, we'll compress the groups into their, like, sizes. Then we get the array 2, 1, 2, 5, 1, 1, 1, 1, 1. Yeah, I know SecondThread challenged me. I guess I can try. I mean, I don't really know how to hack that well, but... have there been hacks on A? No, I'm not, yeah, okay. So, this is just for a demonstration. Right, so this is the beginning of the string. Basically what I'm doing is I'm deleting the whole string, but I'm just not like explicitly deleting it. I'm just using this pointer to represent, this is the prefix that hasn't been deleted yet. Everything to the left of this pointer has already been deleted by some of the operations. Okay, and we have another pointer which basically goes through the array and finds the earliest possible group that we can still waste a move on. Let's call that the orange pointer. Right? Okay. Now this orange pointer is here. So first we have to waste a move, and we can. So we waste a move here, and then this is like 1. And then now we have to do the prefix thing. And so we do, and now this whole thing is gone. So now this blue pointer, because the prefix was just deleted, moves over to here. And this orange pointer also moves over to here because we don't have any more prefix here. So now we consider it again. The orange pointer is here, but it can't waste a move here. So we move it and look at the next one and see if we can. And if we can't, then we will move it again. And if we can, then we delete it and reduce it by 1. Then now this blue pointer has to kill this one, so it does. And therefore we go over here. The orange pointer stays the same. Now we try and waste another move. We can't, so the orange pointer moves over. We try and waste a move. We can, so we have 4 here. Then the prefix will, the blue pointer, the prefix operation will kill this one, so now we have this. Now the orange pointer tries again to waste a move, and once again it can, so we do that. Then we move over, and now the blue pointer kills this whole prefix, which means it moves over here. Now this whole thing is gone. So the orange pointer tries to waste a move, it can't, it tries to waste a move again, it can't, it tries to waste a move again, it can't, it can't, it can't. So we're at the end of the array, and it means all of the groups are size 1. So we have to use our single element operation to delete one of these groups, unfortunately. So we might as well just do it from the beginning. So we do that, then we move the blue pointer over, so now we have to use the blue pointer again, so then we move it over again. So now we've killed 2 in 1 turn, and then we kill 2 in a turn again, and then we eventually, when the blue pointer reaches the end, the string is dead. That's the idea of how it would work. Is that good? I guess we'll read it. In the string S, you have to reverse it. Yeah. Well, the orange pointer's movement, like the time you would move the orange pointer is if either you delete the whole prefix that the orange pointer is on, or the orange pointer points to a group with size 1, and so you can't waste, so you have to keep moving. Like, you only move it if it's impossible to use that group anymore. But if you can use the same group multiple times, then sure, you can. Well, this is weird. Minimal number of... boy. Well, this is fun. So we have a string. We have to swap stuff, and just once we do the swaps, we gotta like reverse the string. Okay, this is where I die because I just don't know how to do this stuff. But we'll try. Let's just like generate the reverse string. How bad is this actually? I'm not sure how bad this would be. Yeah, it actually does seem simpler than I thought. Okay, yeah, okay. This isn't the hard part. I'm expecting the hard part to come soon. I know F and G had like 70 solves total. By the way, SecondThread ors. Didn't he like get 7th or something? Oh my god, he's doing great. What's the word? Smoked? I think that's the word. Definitely the word is smoked that we're talking about here. Let's take some string, A, B, no, how about this? A, C, B, D, C. Then the reverse of this string is C, D, B, C, A. So this C has to come from somewhere. So we might as well move the closest C we can to it. Which will therefore, so we kill this C basically. And now we have this remaining string A, B, D, C. Okay. So everything on this like prefix gets shifted to the, like it gains an index kind of. So then we can use, we can do D here, and this D has to get something from here, so we might as well do that. And then everything on this also gains an index because we have to shift all of them to the right. Kalen, Golan, Ors. I don't like you guys. I'm gonna draw the word Kalen, Golan in orange so you know it's not me. It's orange, you see? Orange. I should do some like inspect element where I make a thumbnail where I change my handle to that. I can do that for like the IGM video or something. Probably not, but something. Okay, right? So like basically that's how this is gonna work. So we always want to take like the leftmost of anything. IGM in the next contest. Well, I don't know. We're pretty close, aren't we? We're very close, yeah. 75, 25, 83. We're 17 away. Just look at this. We're like, the dot is touching it. It's that close. We're touching the dark red. We're just not there yet, which is really sad. Okay. Yeah, sorry, I should have responded to that. Why do I not use a better looking editor? Because I'm lazy. And everything else is in light mode anyway. Like Codeforces is in light mode. I mean, Paint is in light mode because I hate you guys. And so I might as well make this in light mode too, to just, you know, be consistent. But I mean, this setup is fine. Also, I use bad IDEs to kind of prove a point. Like I got to Grandmaster using Replit, which if you don't know what that is, it's like terrible. So I don't even like, if you don't know what that is, good. But if you do, then you'll understand the point I'm making, because there's like, IDE just doesn't matter. Just do something that's comfortable for you. And light mode is comfortable for me, which is why I use it. Okay, back to the problem at hand, right? So for this B, like we want to use the leftmost B because this B is on the left. Yeah, I care about LGM. IGM's I can't think of a metaphor, but it's something. I think IDE in light mode gives you an IQ buff of like 100 or something. It's probably why I'm beating SecondThread in rating right now, because he uses dark mode and I don't. That's like the sole reason. So, God, I've gotten so distracted. All right, so for like any character, we want to use the leftmost position of that character. And then once we do that, we know that every character that isn't swapped is going to like maintain their relative position. So when we move some character to the beginning, it's basically like saying, everything to the left of x gets shifted over one index to the right. And everything over here doesn't really change. And so basically we're interested in the current position of the leftmost, like for example, b. And the way to do that is we just need to count the number of like prefixes that have been applied to this, and we can do this with something like a Fenwick tree. I think that's the intended like idea. It might be even easier than that actually, but this is simple. Forgot to open my own files. Okay, look, I have a solution. Tell me if it's supposed to use Fenwick tree or not, because if not, I'll look for something like nicer. But I mean, this is actually pretty nice itself, so it's not that big a deal. Okay, cool. So what I'm gonna do is store indices of like everything. Cars 26. I'm just gonna like have this as a vector of all of the like positions of the characters. First step. Okay, so like, all right, so let me just show you for everyone who's interested how you would use a Fenwick tree for this. So you have this array, and then at a certain point you're going to pick a character and increment everything before that to +1. But like consider some other character that this gets applied to. That means that the +1 like inciter is going to be on the right. So we're basically interested in asking, instead of incrementing the whole prefix by 1, we can say like this becomes a 1 instead of a 0. And then now we're interested in the number of 1s to the right of this. So that's how you model the problem. You would, instead of incrementing the whole prefix, to find out the increment, ask for the number of 1s to the right. Are there multi-tests? There are not. Yeah, sure, I can. Okay. Now this is for S, and we're going to go through T. Actually, I'm going to make this a deck, because that way we can pop from the front, and that makes it easier for me. I mean, you can also do it by maintaining like 26 pointers to each of the characters arrays, but like whatever, I don't care. V dot, wait. Okay, so we're interested in the number of activated characters to the right. And basically what we can do with a Fenwick tree, all we can do is query a prefix. So one way to do this is to simply like query this prefix, right? And then all the activated characters to the right is the total number of activated characters minus this prefix. So we can do it that way. And the total number of activated characters is exactly equal to the index I, which means that we have I minus query of I plus, or not, it's the like position +1. I minus b dot query, and it'll be v, yeah, or v +1 because 1 indexing. Then we add 1 to position v +1, again 1 indexing, And basically this is just this, right? Answer plus equals v minus I. Is that it? I feel like that's it. That just like feels right. So we guarantee that v is going to be greater than I because like it's just how strings work when you delete stuff. 33. Oh boy. Okay, never mind. Cool. So what's with this then? Let's see. TI. Let's make sure this is actually right. So this is 6, 7, 8, 5, 4, 1, 2, 3. We're doing too many? Maybe we're doing too many. How the hell is this 10? How is it 10? That's like not even... That's not even 0 index. That's like... What the hell? What the hell? How is it 10? And what is it before? So it goes from 3 to 10, which means that it detects 7 things to the right of it. Oh wait, we want to update this first. Okay, because this is the original position. Yeah, we want to update the original position, not the modified one. So now I get it wrong again. And this should be I plus 1 now. Yeah, real index, my bad. What? I was trying to be cool and like test my program fast so we can submit it, and then I just totally screwed it up. Let's submit NST equals S reverse, put the cars in, bit, yeah. We got this. Hi, Lior. Okay, we got E. So now we move on. Oh my god, 6 and 5 solves? What the hell? And the second thread already has F. He got F before I even got E. Stream pace is amazing. I am from the US, in case you're wondering. By the way, okay, let's, so you asked for an example, let's do that out then. I'm gonna do, I'll take their sample and like shorten it, something. Let's do that, I gotta open E. So let's do like ICPC, about ICC Guru. Let's just mess with their sample a bit. Right, okay, so we're here, and we're gonna do this stuff. So the reverse string is U, R, U, G, C, C, I. And now we go here. Where do we go? Okay, so we have to match something to this string. And, well, we might as well match this thing that's like closest to the left, because if we match something to the right, that's like pointless. So basically what we're going to do is we're going to move this U over here, and then we end up with the string U, I, C, C, G, R, U. Which means that essentially everything in this range is shifted by 1. And so what we can kind of do is we can simulate shifting everything over by this range by using something like a Fenwick tree. And here's how this is going to work. What we ultimately want to do is we want to count the number of shifts that have been applied to this character. One way to do this is to use a range update. For example, we can range add 1 to all of these numbers. Then once we figure out this character, once we need to use this character, we can figure out that it's been shifted once, so its real index is actually 1 to the right. And then the answer for this character is just how many times you have to move its real index over here to make stuff work. But okay, well, range updates are annoying. You know, like lazy propagation or something. But the defining factor here is that we only have point queries, which means that if we want to count the number of prefixes that are applied to this, it's the same as counting the number of elements that would apply a prefix, right? So every element that's going to apply a prefix is going to be the right, and it's also going to be activated in a sense. Once we move this character, we can, instead of saying that it applies a prefix here, we can change it from a 0 to a 1, for example. And then this element being 1 signifies that we added 1 to this prefix beforehand. So then once we ask for this character, we can query the number of 1s to the right of this. And that gives us the number of prefixes that have affected this. And so, well, with a Fenwick tree, we're constrained to prefix sum, so what we can instead do is we can divide this into 2 ranges, and we can say that the answer is this blue range minus this purple range, which will give us exclusively the red range. This is an interesting equation we're using here, but yeah, we want the red range. We want the red range, so we do that. Anna, do you want an actual case? Here's how this would work. Someone give me confirmation in chat. Do you want an actual dry run or something? Okay, here we go. So let's think of the Fenwick tree stuff. Initially, every element has value 0. I'm not sure how good this case is going to be, but I don't want to do one that's too big, so that's annoying. So we begin with this character. I'm going to use my pointer notation again because why not? And so we want to find the leftmost U. And then we want to find where it actually is. So first, how do we find the leftmost U? Well, what I'm doing here is I'm basically saying we're storing the indices for each individual character. So for example, I would have index 0. This is 0. C would have indexes 1 and 2. G would have indexes 3. U would have indexes 4 and 6, or indices, I don't care. R would have 5. This handwriting's terrible, but that's the basic idea of this. Then, now that we have this, when we have a U, we're interested in the leftmost U, so this is just the front of this list. And you can maintain this list either with a stack by making the list backwards, or with I use a deck because it's just easy. But somehow you have to have this list. And then once you do that, you pop something from this list, right? So we begin with this U, so we're interested in this 4. Now we have a 4. So now we ask for the number of times this U has been shifted to the right, which is equivalent to asking how many 1s are on this suffix, which is also equivalent to asking how many 1s are on this purple prefix, and then how many 1s are inside the blue thing. Well, the ones inside the blue thing is just like the number of operations we've already done, which is the position of this pointer. In this case, it's 0. And then the zeros in this prefix is also 0, so we get 0. So therefore, this index stays the same. So now we know that this u is in position 4, so we have to shift it 4 places to the right. So now, undoing all that, the answer is initially 0, then it becomes 4. Now we move this pointer over here. And we ask where the r is. Well, the r is at 5. Oh, and now that we do that, we update this u to 1 because now it's been shifted over all the way to the left. So now we have r at 5. And we ask for the difference. We ask for this prefix, which has 1, and the total, which also has 1. So we have 1 minus 1 is 0, so the index remains 5. And thus we have to shift it 5 minus 1 places over, which is another 4. So then the answer is 8 after this. So then we update this to 1. Then the second index of u is at 6. So we delete this. I'm confusing myself with my own colors. Here we have this. We ask for this prefix and the whole thing. Both of them are 2, so we get 2 minus 2 is equal to 0. So this is still unshifted. This is a great sample, I am realizing. So then this remains 6, and therefore the answer is another 4. Interesting. Interesting. So we get 12. Alright, now we ask for G. G is at position 3. Of course, I'm using 0 indexing here. G is at position 3. However, now we actually do have an effect on this. Because right here we have this, and we're asking for this prefix. The whole thing is 3. This prefix is 0. So we get 3 minus 0 is 3. So this gets shifted 3 to the right, which means this is 6. So now we need to know 6 minus 3, which is what we add to the answer, and that is 3. So we add 3 to the answer for this one. Why did I write that here? Yeah. So now this gets updated to 1, and we add 3 to the answer. Okay, I'm going to go a bit faster now. So like, here we ask for C. This is the leftmost C. And it's still optimal to use the leftmost because all of these are going to be shifted over anyway. So we know that like this is going to be matched with this suffix kind of. This prefix is going to be matched with this suffix. Or whatever we do, the elements are going to be in their original order. So we still want to match it in like leftmost first. Oh, I forgot to move this over. But okay, this C is at position 1. It has 4 ones to the right of it, so it moves to 5. We ask for 5 minus 4, which is 1, so we add that. Then this becomes a 1. Then we ask about this C. There's a lot to keep track of. A lot to keep track of like by like writing it out, but not really in terms of code. So we ask for this C. This C is at position 2, but it has 4 ones to the right of it, so it moves to 6. 6 minus 5 is 1, so we add 1 to the answer. So we get rid of the other C. We have 17 here. This becomes a 1. That was not smart. This becomes a 1. And then now we're left off with this I. This I is 0, becomes a 6 because that's 6 rights, or 6 ones to the right. 6 minus 6 is 0. So the final answer is 17. And that's basically it. Yeah. That was a, that's basically how might u works. Yeah. And you don't actually have to query the whole thing every time. It's just it's just like based on the position of this pointer. So you can figure that out. And be careful to update the original indices, not the modified ones. Alright. I deleted some of the Kalen Golan. Okay, I think that's a good thing then. Alright, so it seems like reading F and G at the same time, I don't know. These are both hard, but I guess F is a bit easier. So let's go for it. Character has a gun with magazine size equal to K and should exterminate N waves of monsters. Aiming and shooting are instant, exactly one bullet to kill a monster, but reloading takes a unit of time. Huh? Okay. So eventually you have to clear all the waves. Now that's fun. Okay. So first things first, the answer is some multiple of the so let's consider these intervals, right? What happens when you like reload? Well, so no matter what you do, you're gonna have some multiple of how does this work? You don't throw the remaining bullets away after eradicating all monsters. So it kind of just depends on the last interval, I guess. But say you like you kill some X monsters here, and then you do reload before you get to the next one. Then the amount of bullets you've cost is some multiple of K. Because you throw away full magazines or use full magazines each time. Then similarly, when you get over here, finally said that word right. Even if you kill some X and then you don't reload before you move into the next one, eventually you're either gonna use the full magazine, reload, or finish at the end. But if you use the full magazine or reload, then either way you end up spending the full magazine. So essentially what I'm thinking is the answer is always going to be a multiple of K, except for the end, in which case you don't always have to throw all the K bullets away. So instead of counting the minimum number of bullets, we can instead count the minimum multiple of K we have. And another thing, how does this work? So I'm thinking some sort of DP or something. So here's the idea, right? Well, obviously you start here. I'm using gray as a color, I don't know why. Obviously you start here. So either you're gonna do some shooting here and some shooting here and every possible point in time until you kill all the monsters here, right? And then at this point, you have some fraction of x. Let's call that y. Y is possibly equal to x, or 0. There are two things you can do. Either you reload, in which case this is kind of like a reset, or you continue into this point. And then there are two things you can do here at the end. Either you reload, or you continue into this one. But we can kind of combine it and say that we go from here to here instead of just continuing from this and then into this. So now once we get here, there are two possibilities. We reloaded just last time, or we continued from some point into here without ever like forcing ourselves to reload at the end. And I think that's the way this works, which means that it's kind of like dynamic programming, where you have, let's say, dp of j is something. Then either you don't reload at all, going from here into here, or how do we define dp? What do we define it to be? I mean, it screams dp, I think, but it's interesting to work this out. Maybe we need two different states. Yeah, I'll look at SecondThread's G once I get to it, but I want to try and solve this first. I mean, okay, it's a stream. We can do whatever we want. Like, we don't necessarily have to stop when the virtual ends. You don't have to watch me. I mean, it's just a stream. You'll get the... If I'm too distracting, you don't have to do this. Because everything's going to be uploaded later anyway. Drinking a dangerous amount of water here. Okay, let's figure something out. So, whatever's going on here is going on. What is going on? It's a good question. So we got to be like here. And either, so we start here. And either we reloaded at some point, or I don't have Nightbot in here. One of you mods can act as a Nightbot. Either we'll like... Alright. We gotta just work this out. Have I completed all the problems from Musical training? Yes. Quite a few of them are not worth it. Like sections, I think 6.3 is what I usually say, and beyond is not worth it. But most of the other stuff is cool. So we get to here. Let's say How's this gonna work? It's rough to work out. I can see why other people haven't solved this that much. So if this is some position here, say that DPJ is like the best answer for having just reloaded before this. Yeah, okay. So say that DPJ is, why did I get rid of that? I don't know, but I'm doing it. So DPJ is giant J. Let's say like the best answer for, yeah, M17. Best answer for, what would it even be? Like it's the best answer for reloaded. Like maybe it reloaded before J+1 or something. And then we can kind of like do push DP or something to figure that out. So the question is, can we even do that? Sometimes we just can't. Like sometimes we're forced to, yeah, sometimes we just like can't. Sometimes we're forced to use all of our time. We don't even have time to reload, which is a thing. So say we start fresh here. Then and then this DP value is kind of like solving this whole prefix. So then we say we reloaded before here. So now to get to here, we have to finish this one and then be able to reload at the end of it. To get to here, we have to finish both of these and then maybe either reload or don't, depending on the answer, I think. It seems like a very, I'm going to read the input, but this seems like a very bad idea to just try and work out while coding because it's just not good. Are these sorted? Yeah. Actually, no, let's be consistent. We'll do L, R, and A. Now we ask, what is even going on? Also, how did SecondThread do this contest? Isn't it like 2 a.m. or something for him? That's some dedication right there. Maybe that's why he wants me to hack his G, because it's like scuffed. So we say dpn ats equals, what is it? Only 17 is fine. Is it? There are 2,000 waves. Each wave is 10 to the 9th. Yeah, it's totally fine. Inf. Okay, now we go through. And we can do n squared here because they just let us. I don't even know how we do it in not n squared, or better than n squared. Now we look for the next position. All right, so we assume we start with x. Run equals k. So now we say the required turns we take are let's just say if DPI is not equal to infinity, because otherwise it would not be possible to even get started. DPI is not equal to infinity. Then we start off with k. This is mandatory. And the total is 0. Then we try and like go as far as we can without it being impossible, I guess. So now let's find the position where we end in. Do we start off with the full capacity? I hope we do. Yeah, you start with a full magazine. Awesome. So that makes it even easier. For hello j plus I, j is less than n, j plus plus. Okay, so this is sketchy. We start off here with like r amounts of stuff. And then to get here, we'll have r plus k, r plus 2k, r plus 3k, etc. So we're interested in the first position where r plus x times k is greater than or equal to aj. Solving for this, we get x is greater than or equal to aj minus r over k, which means that x, looking for the minimal x that does that, which is to say the ceiling function. That is right? R plus x times k is greater than or equal to aj. Do the math. So we do that. Aj minus run plus k minus 1, just to do the ceiling. This may take a while, probably will. Definitely will. If I'm hung on this part, this is going to be terrible. So x is greater than or equal to aj minus r over k. Which is to say x is the smallest integer such that it's greater than that. Greater than or equal to. Which just like has to be ceiling. Yeah. So then we have to go x steps forward. If Lj plus x is greater than Rj, then it's impossible and we break. Otherwise we can go there. So now our position is Lj plus x, which means that toe plus equals aj, and let's see. So run equals, we're doing everything modulo k. So run minus aj mod k. This is what we want, right? Hi, what's up? How you doing? I am not doing well, to be honest. This is great. So we subtract aj from run, and then we do a modulo k, so we like get some stuff going on. So the new position is this. If this is greater than rj, then we're like screwed. How do we assume that we reloaded before this? Don't think we can. This feels a bit wrong. It's like some nagging feeling in the back of my head. Some spidey sense about this DP that's like happening right now. Sorry for the chair squeaks, by the way. That's just like going to happen. Like say we're here and then we can't reload. Does that mean that we need an extra state for here if we reload here? It just feels like it like doesn't. Because it means we can't start fresh from here anyway. But somehow we have to consider having gotten here, right? Is this a necessary state? Actually, no, this is straight up isn't optimal. If we reload here while wasting these bullets, then like we can just use these bullets on this range anyway. So there's literally no reason to do that. Okay, so I think I'm fine. My spidey sense is wrong, as always. And therefore, is that it? Is that, what else do we have to do? It's still possible, the run is still that, total 0. Now we have to update DP. So if P is strictly less than RJ, then it's possible to do this. DP J plus 1 equals min DP J plus 1, and then it's tot plus run. Because we waste another run bullets, which means that we like cost them in reloading. But at the same time, we like already have the total we have. So I think that's the way this works. And then we say if it's possible, ants equals min ants tot. Because that means we got to the end without doing anything. Or without having to like reload between intervals. Okay, there's no way this works. There's no way this is going to work. 15. Okay, that's like lower than the answer. What? How's that lower than the answer? What else do we get? Do we get this -1? Yeah. If ants is equal to infinity, make it -1. So at least we get that. That's good. That's a start. Let's try another one. 1, 5, 100, 102, huge number. Cool. How's this awesome? I just failed the sample. It's not exactly the best outcome. I would would not say it's the best. Wait, this is like the only case where the DP actually does anything, and it just absolutely does terrible. How is it 15? That part is like confusing. Because it just means it like totally ignores everything. Oh wait, total has to be DPI. That makes sense. Now does it work? Indeed it does. Okay, well we gotta try some more cases because this is terrible. Let's try something better. So let's do 7 and no, not 7. Jesus, am I trying to 410? Nice round number. So we get 1, 5, 30. No, 27. I don't know. 5, 6, 11. 6, 7, 6, 10, 10. 10, 10, 10. So we're obliged to reload here. What's the answer going to be? So 1, 5, 27. So that first takes 27. Then we can use another 11 there, 38. Then we use another 10. So the answer has to be 60. Indeed it is. Okay. I don't know. This is probably going to get wrong answer. I don't believe it. Actually, let's just look it over again. So we have all arrays of length n, li, ri, ai, inf, dpn, ans equals infinity, initialize all dp to infinity. So if this is not infinity, and we start off with k bullets, we have dpi bullets used so far, we say it's possible. And now we go through all possible next indices. We say that this and j is less than n minus 1, because we don't update dp to like something bigger. That's actually going to crash. This is f right now. I think it's about done. This should be j is less than n minus 1, right? Because otherwise we'll add to n minus 1 plus 1, which is dpn, which is not what we want. So this is the number of this is the next position we're going to be at, obligatorily. Then we add aj to total if it's possible. We update the number of bullets we have, subtract aj, then take it modulo k, and then we update future dp values if it's like a thing. Let's move this over to here. 6, 6, 10, and then I don't know, 6, 8, 19. Let's check this one too. And then if it's possible, we check the answer. If it's infinity, we print 1, and then, yeah. We're very close to doing F, I hope. So this is going to take 38. How does this work? So this is 7. Then that will take... Oh, that won't be possible. This should be impossible. Yeah, and then we maybe make this 10. Then this will take us... That will take 30 in the beginning because we have to reload for that. Then we do this here, and then so the answer should be 69. Nice. That wasn't even intentional, but we got it anyway. Amazing. Great. Okay, well, what's with that? Wrong answer on test 6. What do you mean by specs? Like computer? They're not that good, I don't think. I don't have an OP setup. It's just my laptop that I use for everything. Actually has a broken okay, stuff is broken. Let's go hunting for a case that kills us. Obviously that's impossible. still be 69. If we make this 3, it'll be 59. Plus 4 and then 11. 38. 48. 67. 38. 48. 67. That should be 67. Okay, that's concerning then. What happens here? Here's something that's wrong. Probably some stupid mistake. Why can't we get here? X is 2, then 1, then 1. So here, that's fine. Get to 1. Ah, I see, yeah. Oh, we still do have to reload. Okay, so that's right. Whoops. Still takes that. If we make this 14, it should be 79. Oh, this isn't even allowed. What am I talking about? Five, 6, 2, still 9. I don't want the test here. Maybe if we have freedom. Oh, this should be if P is less than, I guess. I see. So I think it'll still think this is impossible, even though it should be possible. Yeah, because we can do this. Reload here. Reload. Okay, so this should be if j is less than m minus 1, and we can reload before the next one, which is to say p is less than lj plus 1, because that's the next left point. Now we get an answer. Okay, and that takes, what time is D? I'm honestly not sure. Although, when I was explaining D, I did actually write the letter in the header eventually, so you can look for that in terms of paint. How many tests do I plan to solve from ARC? As many as I can, basically. I think I'll do it a virtual style, because, like, why not? I don't know. Yeah, ARC is pretty hard. I mean, D is expected to be difficult. So 1, 5, 27. Reload before 14. Otherwise, it'd be impossible. So 30, then 50, then 60, then 79. So that looks right. Give her the debug prints. Make sure it still works on samples. Didn't copy the sample. 30. -1. 1. I don't see what the point of this sample is. Oh, maybe it's to test the end thing. Okay, that looks... Sure. Okay, that's F. Looks like we're doing fine. So he attempted G. Did he like clutch it, I guess? Okay, well that's the idea for F. It's basically like a messy dynamic programming where we just, so DPJ represents the best answer where we reloaded strictly before J. That is, we start with full capacity. Then the transitions is, I think push DP is much easier to do here. So we say we start here, then we just kind of like simulate it. And we ask, can we get to the end? And can we get to each possible interval without like it being impossible? And if so, then we update future DP states. And if not, then we just kind of like cry. But either way, it's basically just like once you have a DP value and you know that you like start with a full capacity, it's like simulating the process, which is simple. Or it's like it's math, which is doable. It's not like any sort of algorithmic stuff. That's the idea for F. I guess I have a few minutes left for G. SecondThread wants me to hack his, although I don't even know how to solve it, so I don't know what he expects. N is 18. Okay, that's fun. Screaming bitmask or something then. You're given a DAG of n vertices and m arcs. The ith arc leads from the vertex xi to the weighted DAG. Select an integer AV. I'm going to select the numbers so that all BI are positive. The value of the expression, the sum of WI BI is the lowest possible. Strictly positive. Okay. So it's find some topo sort, right? We want to minimize the differences. So if we have something like 1, 2, 3, 7, and when we have some edge like 7 to 2, like this is bigger than it needs to be. We can make this something like 4, and then it could be like 4 to 2, and that'd be better. I'm more interested in seeing what SecondThread did and solving this for myself. What? Ah, these guys are trolls. Okay. So you got some components, they're independent. What else? It's kind of a topo sort in that like you want consider some vertex, then okay, n is 18. This is like incredibly important. We have to use that somehow. Oh, there it is, you got it. Somehow we use the fact that n is 18. Which I really don't understand. think maybe the way it works is there's some ordering we use. We say we have some DAG like so. Boom, 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 boom. I don't know. We have this, then this, then this, then this, maybe like this. Can even have this too. Okay, then we need to pick some way to number the vertices so that like all weights are positive, which means that every edge comes from a higher number to a lower number, and the expression is minimized. So what does that like mean? What does it mean, man? So the numbers can be small. The numbers are going to be between 0 and n-1. Because if we just do a topo sort, like that's going to satisfy the first condition. Or if we do like the reverse of a topo sort kind of, and make all the numbers distinct, then that's going to satisfy the first condition, which means we can make it work with numbers between 0 and n-1. So let's say we have that. We want to make as many of the numbers as small as possible. Well, so what I'm thinking is we number the vertices in some order. Like say we had n being small and therefore we had n factorial time. Then we could say number the vertices in some order, and is that even optimal? I don't even know if that's optimal. But we basically give each vertex the lowest possible value it has. Doesn't seem like it's optimal. It's not necessarily optimal. Do I know Gaussian elimination? I actually don't. Well, I mean, I'm familiar with it. I don't know how to code it. Or that's all systems of equations and stuff. All that from like high school math. That's all I know. That's my background on it. Okay, so like we got 4 minutes here. I don't think we're getting anywhere, but we can try to get the idea still. One, two, two, three. Well, this is awkward. I'm getting nowhere. Does it even work if we we just try all possible permutations and then we order the numbers like kind of greedily based on that permutation? And say we do that. Well, we say, like, for example, this number has to be 0. Well, okay, that probably doesn't work. We kind of like have to be smart about this. This is sketchy. Don't really understand what the problem is here. Like, we have this number here. Let's say this is 0 or something, and this is also maybe 0. Okay, then we know this number has to be at least 1, and this number also has to be at least 1, and this number has to be at least 2 because it's 2 away from this. Maybe the problem is, like, so we can solve for each component independently, that's fine. What we're interested in is what's going on. Yeah, we can't do, I mean, I'm just saying hypothetically. Of course, 18 factorial is like enormous, but I'm saying hypothetically, if that would even be a solution, maybe we could optimize it with some like bitmask DP or something. But I think even that is just wrong. So let's like ignore this. So the question is how to handle weird stuff like this. Or maybe it's, yeah, okay, I see the decision issue here. Like, we will have something like this maybe. Situation like this. So we can make this 0, we can make this 1, 2, and 3. And the question is, do we make this 1 or 2? Yeah, 18 factorial should fit into long one. Yeah, 1e, 6e15 something. It's totally fine. So this is the issue here. You get stuff like this. And of course, this is a simple case, but it can be like complicated much more. But maybe essentially each number gets a range of values that it like has to be within. Each number gets a range of values. What's a smaller number? What's 9 to the 9th? Just a hypothetical bound. That's equal to 3 to the 18th. Nice. What's 9 to the 9th though? Is it like a thing? How many ranges do we really have? This feels like you can brute force out these ranges. So like, say the bottom number is 0, because it might as well be. So what do we define as the bottom number? Or we can make it like 100 or something to give us space for negatives. Then it's like all the other numbers are kind of fixed. So for each component, fix the number at the highest or the deepest depth. And all the other numbers must be at least 1 higher than that. And all the other numbers also have some range that they're constrained to. It's 8 to the 8th. I think that's the bound. I think 8 to the 8th is the bound of like brute forcing all the ranges. Okay, here I'm gonna do a makeshift poll. So if you want me to so if you want me to try and hack SecondThread, type in the number of viewers we have right now in the chat, and otherwise type in 8 to the 8th. Make it a makeshift poll. Makeshift poll right now. Okay, majority is for SecondThread, it seems. Although people are saying it multiple times, which is weird, but all right, of the people that have spoken, of the people that have cast their ballot, seems like we're hacking. So let's see what he did. Also, Or is 8th place. Let's see what he did. Does he have, oh boy. Is this, the hell is this? Simplex? Okay, let's read this. What does this even do? We're also going to test this on custom invocation because I don't even know how to do this. He uses Java 11. Is that right? Java 8. Okay. What exactly did he say? Did he say it's possible to hack, or did he say it's straight up wrong? Or did he say it may be possible to hack, or did he say it's just straight up wrong? Also, what the hell is a simplex? Okay. Is it like a pruning thing? Oh, God. I don't know how to do this. What does he expect me to know? I don't even know what that is. He said very hackable. Okay. So maybe wrong. But it doesn't mean it is wrong. So he creates nodes. Nodes are just 2 and wait, what? Oh, node is an array list of edges, and it has values. I'm gonna rename the stream. Call it trying to hack SecondThread. Let's just understand how this works first. So a disjoint set is this just DSU? A equals find A, B equals find B. This is just DSU, right? You guys are allowed to help me here now, because I don't know what a simplex is. So, yeah. So this is DSU. That's normal. It looks like DSU at least. Okay. So first he has components, and you read edges, and take the weight, unite the two nodes into components. I don't know, maybe someone does. I gotta have some experienced viewers in here. Actually, maybe not. So you make the... I shouldn't watch his stream on... I shouldn't watch his video on stream. I don't think that's fair use. But, we'll figure this out. I mean, okay, if it's just like applying a simplex, then like that's fine. I can figure out what that is. Yeah, this is gonna be a very weird stream from here on out. I don't know, how long will I try this? Because I also have to do ARC at some point, and it's gonna start getting late for people. Well, yeah, but I mean, what it's gonna be is I'm gonna be watching his screencast and like dumbfounded at his, like, the expansion levels of his brain that he exhibits when he writes this code. Node and then nodes. Don't spoil ARC yet, because I'm gonna do it later. Okay, so for each node, for each edge, you have to figure out what a simplex is. Let's just like read up on that. Because, algorithm. So what does this do? What's it supposed to do? It's supposed to maximize this subject to... Oh, so the hackable part, I guess, is that it has to be an integer? Weird. And it just happens to work. Oh, it's a matrix. Okay. Well, it's just a casual matrix. So maximize c to the tx starting vertex. Interesting. Interesting. Very interesting. So this is objective. And then, so this basically says double R equals new double N. So this is ID. So you set something to 1, set the negative 1, and then this is like something. And then you do something here. You like make something happen. Why does this check if the parent is something? How does that work? Is it DSU for directed graphs? Feels like it wouldn't be. So if it's like the parent of something, if it's just the parent of its component, I guess. Ri equals 1. It's 20. This makes sense. Oh boy. So there's just some stuff going on here. Okay, I'm going to assume the simplex is correct, and then we have to figure out what it does. So this will operate on linear programs. Okay, Wikipedia sucks. Let's go somewhere else. This is like going to be terrible, by the way. Let's try this. Okay, looking at the code is not going to help. What we need to do is get the idea and then figure out how to... Is this something you wrote? Optimized solution on a convex polygon. Made up of a bunch of lines with constraints. Alright, I'll go for 15 more minutes, and if we get nowhere, I'll just stop. This is like totally stumping me. This is something he wrote beforehand expecting to use it, and indeed it actually did become useful. Nice. I don't get how to reduce this to anything. Maybe we'll try for 10 more minutes. Yeah, this is gonna be sad. Indeed, it will be sad. I feel like we don't even have to like know how this works or anything. all we basically need to do is, the problem is Java. Like if they were both like C++ programs, we can run some like bash or something, but a lot of other supposedly correct solutions are going to be something else. What are other solutions that people used? Are they something else? Like the top guy, for example. He did the same thing? No, he did some like bitmask stuff. Did anyone else do the same solution? SecondThread unique in that regard. No, it's just a template. Wait, what? Is this flow? Oh, there are like so many different solutions for this. Huh, min cut. Interesting. Is that another way to do this, I guess? That's fancy. So, okay, well, looking at other solutions is not going to save us. What we're just trying to do is make it so it's like rounding is a problem, I guess. But when would rounding even be a problem? It's like when it changes the solution so drastically that it... How big are the tests? Another question. I guess it would be a solution where there's a better solution that uses decimal values than ones that only use integer values. Maybe? But how would that even happen? And then rounding is enough of a problem to make it... I'm going to assume that's the way to hack this, because I don't know any other way. It's that basically, I guess there's a better solution with decimals than there is with like values. And that it still satisfies the constraint that they're more than one apart, I suppose. Let's take some chain. Obviously, the best way to do this chain is for these to be consecutive. So let's say that this is 3, 4, 5, 6, 7, and 8. And then what's happening? Well, this is going to be like... Let's just draw some nodes over here and see how we can make the edges happen. And we'll say all these edges also have weight 1 because they don't really matter. I mean, clearly it's correct for a lot of cases, but question is there something that screws over the simplex? Or is there something that screws over the thing? Okay, yeah, so reading most of the code, I guess, is unnecessary. The problem is there a solution that gets screwed over by rounding? Or is there a test case that gets screwed over by rounding? I guess it would have to be something complex. Like, say this. This is definitely complex. Let's draw this bow. So we have a bow graph, and then with this bow graph, what we can do is we can try and come up with weights for this, maybe? Yeah, I go to school for work. I don't know, I guess it's got to be more complex than this, probably, but... Right now I'm accepting SecondThread's challenge. And also failing, but I'm trying. There's an attempt, you know. It's not working. There's no reason to ORs. It's not working. I know what the code's doing. What I need is like a case for it. Alright, let's just try this. So if we take some large test, and then we're going to get rid of the round part, maybe. How bad does it get? Take some large test from the books. Like, for example, this one. That's almost exactly perfect. Let's try some more random ones and see if like anything happens. Because you see, these are all almost perfect integers. So maybe, yeah, 04, okay. What does it do for samples? Okay, so with this bow graph, what can we do here, right? Well, we got, maybe we get rid of this node, make it slightly weirder. All I want to do right now is see if it's even possible to make it so the doubles, like, don't exist. Let's try like this. Because I don't know how he enforces that it has to be an integer. How many does this use? 8. And then also 8 edges. It's like 1, 2, 1, 2, 3, 1, 3, 4, 1, 5, 6, 4, 5, 1, 5, 6, 1, 1, 7, wait. 1, 7, 3, 7, 8, 2, 8, 1, 8, 6, 3. Is it still integers? It is indeed still integers. Let's see what messing with stuff does. What if I comment this out? It's just gonna totally screw with things. Does it make it the same answer? Still works, surprisingly. Okay, so what it's doing is it's making this 1, making this 1, and making this that. Which is indeed optimal. So let's get rid of stuff like this. What if it's like this? No, that wouldn't even make sense. I'm 70. Yeah, I guess I am. Or is this a word that should never be used with my name, like in conjunction? Unless it also has anti as a prefix, in which case it's totally allowed. But otherwise, it should never be used in conjunction with my name. It's just not a good idea, too. Oh, using SecondThread as clickbait is working. Jeez. So either we hack this or we show that it's right. How do we even show that it's right? Well, if all solutions are integer solutions, then it's right, right? So let's do it like this maybe. So we have something here to distribute. See the way this is going to work now. It's going to kind of give it all to he uses double, so I don't think we can kill it with precision. That's probably not going to work. But 3, 1, 3, 6. Definitely don't think we can kill with precision, but something we could possibly do here is make them even. But it still seems to like integers. So add equality, just say that like this has to be equal to 20, the top values. Oh yeah, 5 edges, that's true. Although it shouldn't, doesn't make a difference. Nothing is going on right now. It's kind of being sad. And this says that all of the values. Oh, I see what it's doing. Okay, that's fine then. Okay, okay, I understand the code then, and it's basically doing what I expect. That's a smart way to do things. Just like have some other algorithm do everything for you. So I am not a smart hacker man, but I can try things. Let's go back to the original graph. An edge from 7 to 2. So what does he represent the cost as? The cost is value times the sum of. So for every edge, which is the start of, like for every edge, it's W times value 1 minus value 2. And therefore it's W times value 1 minus W times value 2. And so we can consider it like this is the out degree of a node and this is the in degree of a node. That's smart, I see. That's very smart. Okay, that makes sense. Is it correct then? Is there a solution to this that has problems? By the way, is there anything I need to answer in chat, or is it fine? Practicing is a good idea. So one interesting thing is that the sum of costs is like 0. What's going on is that I'm failing to hack SecondThread right now. So the sum of costs is going to be 0. Because for every like you add what the hell? You add plus W here and then minus W here. It's a very weird problem to think about like this. It's interesting that all of the cases we've tried always form integers. Show some crazy hack ones maybe. Does this get even close to not having integers? 9999999. Great. It's like a very slight precision issue, but nothing close enough to even make a difference. This is like uber sketchy. Yeah, I get why it feels like it should be hackable, because there is, like, it's some problem. Okay, what if instead of trying to hack, we like think about proving that the optimal solution always uses integers? And well, okay, so each number has some integer cost. This has, for example, this has cost 1. This has cost -1. This has cost 0, but this weight actually doesn't matter. This has effect 0. Oh wait, this has effect 3. This has effect 0. This has 0. This has 0. This has -4. And this has -1. And we also have some constraints that these numbers must have, like, integers. They must be like 1 apart. So we can apply the postulate of, like, this number has to have a value. So let's give it a value. Let's say this is 20. By the way, I'm using this bow graph as my thumbnail. It's like perfect. So now that we have that this value has to have a value, like, I don't really see a point where there would be an optimal solution that uses doubles. Maybe it's that, like, there's an optimal solution that uses doubles, and there's also one that, and it's the same value as one that uses integers. Oh, you can send the link in Discord, you know, if everyone joins the Discord, that would be great. Like the Discord is right here in the description. You can just join it right here, and then you can like not have to send links in YouTube chat because it doesn't let you, but you can join the Discord, which I've been saying since day one. Join the Discord, and then you'll be able to post links. If for nothing else, do it for that. Do it for that. Okay, so have you guys joined the Discord yet? So my intuition says that there's always like a solution with integer values. If anyone knows how simplex works, does it try to like maximize something, or does it find like of the possible solution space, does it find like any random solution? That is, meaning that it could possibly find one that uses doubles, or does it find specific ones that are on like edges of stuff? Because if it is, then I think like everything's going to be integers. And if simplex works that way, then if there's an optimal solution with only integers, then there should be like simplex should work. But the question is, does simplex works that way? And that I don't know. So that will depend on something else. What we can try to claim is that there's a solution with all integer solutions, or with all integer values. Just like imagine there isn't, right? Then like what? What does actually happen? Say you have some solution that you claim is optimal with double values. Right? If you have some solution that you claim is optimal with double values, then like let's give some random, okay, it can't be random values. Like there's some optimal solution. Wait, what's wrong with this? Oh, this is supposed to be, no, wait, it is 0. Wait, something's wrong here, because this whole thing should sum to 0. I must have done something wrong. Oh, this should be positive 1. So you want to minimize the cost, which means you want to make these as large as possible. That also makes this large as possible. So first, there exists a solution where some value is an integer. Because if there isn't, then you can just like shift all of the values by something to make it so some value is an integer. This is all confusing. I'm trying to prove his solution. So then does that imply that all values are integers? I think maybe the idea is that like something is either Is it in degree minus out degree? Do I have this whole thing wrong? Oh, it is in degree minus out degree. Okay, I'm pretty sure all these should be negative, which is great. How does this work? Yeah, I'm confusing myself. So I'm pretty sure all of these should be negative. It should be in degree minus out degree. What does that mean? And then you want to like maximize -4. This should be +1. This should be +4. This should be -1. And then this cost here is like, I don't know, say it's like something. Okay, well, alright, for the sake of keeping the stream going, I don't know how to prove that it works, but like I have kind of a strong intuitive like wishy-washy feeling that it does work. It just maybe it can be hacked, but from the little I know about linear programming, it seems like there's got to be some way to scale these values so that they'll be integers. Or rather, maybe you can make them to within some precision factor. Can we scale them? Let me minimize that. Don't really know what this solves. I'm getting more confused by this as time goes on. So my final verdict is that either I don't know how to hack it or it's correct. I believe it's correct, and that there's some way to scale the value so that there's always integers, but I don't know how to prove it. Like, it seems like the same kind of argument for like consider consider this, and then you want to minimize the value of the sum of, say, the absolute values of x minus ai. Then the argument for that the optimal x is the median is that like you basically consider the slope of this function. It becomes a u, and the minimum of this function, actually it's more like discrete, and the minimum of this function is at the median. I feel like it's a similar kind of argument because some value is an integer. Like there's some slope voodoo magic that's going on that makes it so everything else should also be integers. Because everything has to be exactly one apart. And so if it's more than one apart, and unnecessarily so, then you can shrink it so that it's exactly one apart. And if you think of everything relative to the one value that has to be an integer, I don't know, it just seems right. Okay, but that's all I have right now. I really don't know how to hack this. Are we doing the ARC round? Yes, we will in a very short time. Okay. I'm gonna rename the stream. And we'll just close everything because I really don't know what I'm doing. SecondThread ors, as always. Do I do a virtual? Actually, wait, I'm gonna probably grab some lunch because it's gonna be like that soon. So before I do anything else, I'll leave it at this. It's 1 of 5, right? I'm gonna make my own pause screen out of just totally nowhere. Okay, I'm gonna get lunch and stuff. I'll be right back. After that, we'll start the ARC. Okay, I return. We're gonna do some stuff now. First, I have to change the thumbnail so it actually like looks right. The audio stream, oh, whatever. Okay, it didn't exactly prove it was correct, but it's just like wishy-washy, you know, like it just looks right, you know? You know, it just looks right, man. My intuition screams that it's correct. So I'm gonna guess it is, although I definitely don't have any proof for it, so who knows. Y'all know what I'm saying. Okay. Yeah, is that it? We're just gonna start? Guess that's the plan, right? I'll do like a virtual or something. Is this alright? No. Is it possible to hack A's with 1,000 ones? Well, it depends on if brute force will work or not. I mean, if the brute force breaks immediately when it gets above the value, then no. So the problem is with A, every number is like 1, 5 or 1, 7 away from being divisible by 3. Which is just like a problem. I mean, it depends on their code, but it seems like it would break pretty quickly. Okay, I'll do a virtual. Do you want me to do a virtual or just like solve problems? Let's see. Okay, type the view count squared, like the concurrent viewers right now, squared for virtual, and then some other number for not. And then type 7 sevens for just like solving. This is once again makeshift polls right now. Is everything right? Is it set up right? Why is my thumbnail not changed? It's supposed to have changed by now. Is the thumbnail right? It seems like it isn't when I load it on my phone. Okay, so far we're going with virtual. I guess that's what it is. Get rid of soon. It's streaming. Okay, does anyone else care? I guess they don't. So I'll set it for virtual. Set in like 1 minute. And so it begins. My mic is unmuted, right? You can hear me? I've made that mistake before and I don't want to do it again. Oh, E and F both are graph problems. Okay, cool. I'll leave it as that. Pinky or ring finger to type. I don't know, I kind of just like... Wait, let's see. Oh, I use neither. I use my index. I use my index fingers to like type everything, man. It's just like really weird. Alright, 4 cookies, deliciousness A, B, C, and D. Choose one or more from these cookies and eat them. Is it possible the sum of the deliciousness of the remaining? Can they be equal? They can be. I'm trying to go for speed here, so I'm going to do some like very sketchy thing with the map. I don't really care about efficiency. This is OP. Okay, so the idea for this is like with I'm literally just like brute forcing all possible values. So like you start off with 0, and then oh wait, actually what I can do is mb.insert x. So like you start off with 0, and then you go out here, and then you have some number like 7, and you have some number 5, and like 2, and then 1. And then so either you can take this 7 or you don't, right? And then you like do the same thing here. For both of these values, either you take the 5 or you don't. And here either you take the 5 or you don't. And then here the same thing. And so it's like just like a random weird brute force kind of. And then you check if the final value is what you want. Come on. What? Oh, so deleted the declaration. This should be yes, no. And that's just basically the idea. And I think that works. So you read in the thing, take the sum vals. For each value, you insert both. And you just like do it. S mod 2 equals 0, and that's not find S mod 2. It's not equal to val.end. That should work, right? Yeah, it should. So like make sure, you know? Okay. Getting wrong answer on A would be stupid. We're probably gonna do it anyway. Okay. So we got I'm so proud of us, we solved A. Let's do B. Okay, you have n cards number 1 through n. Each card has an integer written on it. Written on card I is AI. X and X be the maximum and minimum values written on students' cards, respectively. If X equals X, terminate the procedure, otherwise replace each card on which X is written with a card on which X minus X is written, then go back to step 1. Okay, that is fine. So you have some, oh my god, that's a big sample. Okay, let's draw out some stuff. Also, I'm going to write the letters from now on. let's draw out some stuff. So you got like 2, 7, 6, right? So you're basically gonna like do the subtractions until this stops being the minimum. So basically it's like until it stops being the minimum, which is basically the same as taking like the maximum number modulo like the maximum value of AI modulo minimum. So each time that's going to become the new minimum until they're all the same. And then once you do that, then it's simple. So let's do that. I don't actually know what V is, so I'm just going to that. Alright, so does it make sense that the minimum value is going to be AI modulo the minimum, or the maximum value of this? Because like, oh, and it's going to be done when they all have the same value, because otherwise, I trust you enough, honestly. I hate you, but I trust you. So, like basically, the one that like maximizes this is going to be the first one that gets decreased below AI, because when you reduce all the numbers to like AI plus AI mod min. No, I did not hack SecondThread, unfortunately. I just think his solution is right. So I don't know if it's hackable. But like when you reduce all numbers eventually to this, which is just like what it's going to be, then the one that maximizes this is going to be the first one, and then you subtract AI, so you end up with this. And that's what the new minimum is going to be. So because doing modulo will reduce each number by at least half each time, that's like the same proof as kind of, what is it, GCD, the complexity of GCD, then it's going to be like O of n log n, kind of. So min equals min AI. That's it. Then set. Yeah, SecondThread deserves a lot of ors. What is it? S.insert AI mod mn. Minimum can't be 0, right? Because the array elements are positive. Yeah. If s.size is equal to 1, then that's just the answer. This is the minimum. Else, and then return. I guess I can do break, and that doesn't matter. Otherwise, then we have to modify the array, kind of. No, this is B. So yeah, So every number is going to become AI plus AI mod the min, except for any number that has this residue mod the min. So therefore, you just gotta like do it. Yeah. Two. 252. That's a problem. So am I printing the current minimum each time? How does this work? What? Oh wait, this should be that makes sense, yeah. $42. Okay. Wait, AtCoder. Whoa. Wait, AtCoder made it so when you copy it, finally copies in the new line. Oh, that's so cool. I've been wanting that for like forever. That's actually amazing. That's so cool, because then you don't have to like hit enter every time. Awesome. C into N. Wait, I want to verify this. So it'll like, yeah, it'll start on a new line. That's so cool. C into AI, min, take the min, find the min, S, put the stuff in. If the size is 1, print the min, otherwise, go for it, man. Looks right. Bam, my min is equal to that, make it that, otherwise it's AI plus, yeah. What? Wait, is it TLE too? What the hell? So it fails on 2 cases, and then like works everywhere else. There's like some bad stuff going on. Oh wait, the minimum doesn't decrease by half. That makes sense then. It's actually not in login. Because perhaps the minimum doesn't decrease by half. It's something else. That is an oversight. Okay. You need something smarter then. I don't think simulation works actually. That's dumb. Okay. There is something else that goes on here. I guess let's say you have two numbers, like 3 and 6, and this is going to be eventually reduced to that. What do we do? Like 4 and 6? Let's add 4. 4 and 6, then this will be reduced to 4 and 2. And I said it was like the complexity of GCD, but it is the complexity of GCD. Interesting, because it's like the idea of taking stuff modulo other stuff. Maybe it just is GCD then. Because it is the... Like with two numbers, you're going to keep taking like the iterative modulo stuff. And then for any three numbers, it's like the case of handling each pair of numbers separately. Because they kind of don't affect each other, I guess. So if some number divides everything, then everything, clearly the minimum will be that. Yeah, it's U specifically I don't like. Okay, this seems like it's just like the GCD then. So some number divides everything, then it will clearly be the minimum. And if something doesn't have the same GCD, then it will like... This is the GCD algorithm, actually. Sure. Alright, wait. So this guy is putting an answer in chat, then roasting me for reading it. I think you can ban him. Yeah. Oh boy, camel problem. Okay, so we have camels, and they all have weights. And n is 8, and that's interesting. So we'll arrange the camels in a line and make them cross a bridge of n parts. While they cross the bridge, you can choose their order on the line. Not specifically have to... I see. And specify the distance between each adjacent pair of camels. The ith part of the bridge has length Li, weight capacity Vi. If the sum of the weights of camels inside a part exceeds Vi, the bridge will collapse. Each camel has a weight. Stuff is 10 to the 8th. Okay. And you have some like stuff going on. So n is 8, unavoidably. And 8 factorial is small. So there are like a lot of parts. So say we're trying a lot of permutations. Is it possible to just, actually wait, what's 2 to the 8th? That's small enough? So we're trying out permutations. Is it possible for it to, what is it possible for it to be? So it's like a constraint that like like a sliding window kind of that. Every sliding window has some stuff going on with it. Can we prove that the answer is always an integer? Nice. So some number to the 8th is like small. This is very weird. What if we like do something to the bridge stuff? So if we have some pair of like Li and what is it? Vi? Okay. Let's say we have a bridge like this of length 5 and capacity 3. We have something of length 2 and capacity like 4. So this will carry like strictly fewer camels and carry more weight, which means that this kind of like dominates it. in a sense. So if we have two things where Li is greater than Lj, or greater than or equal to Lj, and Ci is less than or equal to Cj, then I is going to be like strictly harder to traverse than j. And therefore we can kind of ignore j. If we like sort the things by their capacities, then if we sort the things by their capacity, or by length or by capacity. Let's try length first of all. So here we would have 2, 4, and 5, 3. So basically what we want is that if this is strictly increasing, this is also strictly increasing. Because if we have something like this, we can kind of just ignore it. Because it's, per se, useless. Does that help us somehow? Not really sure what happens. What's up, Gabe? Right now I am dying slightly. Maybe a bit more than slightly. Because this problem is OP. Have you solved everything already? I imagine you have. Like, you take a look at the statement, the solution just like... No, you don't even have to read the statement. Like, you just know the solutions beforehand. That's how easy it is, isn't it? I'm not really sure how to even start this. Like... There's just some stuff going on. No, I'm not doing Twitch. I'm too lazy to do multi-setup. Yeah, C seems OP. Have I muted? It should be picking up audio. I'm just like thinking. Don't have much to say. We can think about D too at the same time. Are they worth the same amount of points? Because last ARC I ended up solving D before C, and it was worth more points, so we'll try that. Maybe it'll help us later. Oh, it's a game problem. Oh god. Okay, maybe not. When one or more bags contain coins, choose one bag that contains coins and one dish. Not necessarily stumped, just like not really sure where to go right now. Choose one bag that contains coins and one dish. Then move all coins in the chosen bag onto the chosen dish. It's a weird version of NIM. Yeah, very weird version of NIM. What the hell is that sample? Oh, it's test cases. Oh, I see. That's a massive sample, though. There's like a ton of everything. Okay. Alright, well that's even scarier than C. Okay, let's go back to C for now. Because the bridge will only unavoidably collapse when like a single camel is too heavy. Because otherwise you can make it so you can put them very, very, very far apart. And that'd be fine. For game theory, I don't really know. My knowledge of game theory is very weak. So I have a low chance of solving this, but I don't. Wait, E is also game theory? Seriously? Yeah, I don't know. I guess it's just like, maybe like Grundy stuff. That's generally what it tends to be when you have games like this. No, I haven't really practiced game theory actually, but like, I don't know, just like, I mean, sets like Codeforces have tags for this reason that you can find like, you can go to Codeforces and get a list of all of the tags that you would ever, or all of the game theory problems that you would ever want by just, what is it, games? And here, now you have a ton of game problems. But I myself haven't. Is there a link? Here, right now, this is it. I'll put it in the description. And you can click on that and it'd be perfect. Not even any effort required. But I mean, you can also, you can start simple and then if there's stuff you don't know, use editorials, I guess. I really don't know myself. Like I said, game theory is terrible for me. Okay, new idea. Each section of the bridge can support certain subsets of camels. Okay, does that even help? Each section of the bridge can support certain subsets of camels. Does that help in any way? Like, say we have some, I don't know what's going on. This contest is not working. Ors, by the way. Subsets of camels, maybe like this. So we know that if we start, if we start do we even do? We want to fix some ordering, like 1, 3, 5, 4, 2, and then once we do this, then we can consider like this. Now we'll say that certain segments means that these two have to be a certain distance apart, maybe, and these two have to be a certain distance apart. Or yeah, it's kind of something like that. Can we use this to make a solution? So some bridge will make it so that maybe like 1 has to be 7 away from 4. And that 1, 3, 5 is fine, but 1, 3, and 4 can't fit on the same bridge. Excluding the endpoints. Okay. Hacker rank, hackfest. I mean, I don't know. Probably not on stream because this is the Edu round, and this is enough for like one day. But I don't know. Maybe can discuss it somewhere else, like in the Discord or something. Can give it a shot afterwards. And we have like maybe these have to be a certain distance apart, and that's fine. Then if we have something like that relates to these two, it depends if it's a hard problem or not. If it's hard, it'll take a long time. If it's, I guess, like read the editorial and summarize. I don't know. possible. Let's see, is this going to get anywhere? If we make these constraints, then we know that like this interval has to be of length at least 8. Right, this doesn't work. It's something like this. Problem is actually something like this. I feel like if we can make these constraints, like this interval must be at length at least 7. Say this interval must be of length at least 7, and then this interval must be of length at least 5, and the total thing has to be this. But if we have some weird like intersection, maybe for example this, and this has no constraints, so this can be wherever. Feels like we can kind of DP this, but it also seems sketchy. That is my idea though. So we can say that for any permutation, for example this, 1, 3, 5, 4, 2, we can use the bridges to say like the interval of 3 to 4 has to be of length at least 7. Which means that all intervals containing it must also be of length at least 7. But at the same time, that also means that there could be some weird constraints happening here though. Like for example this, where, well, how would that even be possible? It wouldn't, but say we had, I don't even know if this works. Wait, how does this be like this? Then like this. And something like this, and that would be a problem. Well, no, it wouldn't necessarily. Yeah, it's not a problem. Never mind. Feels like there's something that just works here. Like if we say that stuff has gotta happen here. Alright, jeez. Come on. I don't know what's going on. This feels right, but I don't know if my feeling is working anymore. So like, essentially we compute for each bridge all possible masks that work for it. And then there are 2 to the, what is 2? And then there are 2 to the 8th times m, or n times 2 to the n possible like masks we can have, so that's pre-computed. And then once we do that, can try all possible permutations, I guess. And then we can say that the interval, like for example, the interval between 3 and something else. For example, the interval between 3 and 4 must be something else. Then we kind of like, I guess we can DP it. One second. Nice, okay. So once we have this, perhaps we have a constraint like this. And there's no constraint or anything else. And then this is kind of like DP, where it's DP of LR is like the highest, the cost, the maximum cost it would require to make the interval of L and R. And the answer is DP of 0 and n minus 1. I have nothing better to try. Why not? That's length. Yeah, okay. what's up? How's it going? It's not going well over here, I would say. Yeah, I don't know. Okay, I think the answer is at most. Should be at most 8 times 10 to the 8th, but I'll be safe. Can't hurt. So, what's my typing speed? I don't even know. I can like hit 100 words per minute sometimes, not often, or not always. What did I define max to? Oh, that's fine. I have exams tomorrow? You should probably do that. I mean, the stream is not that important. You can watch it later, always. Yeah, that's fair, but you should probably still do them. I don't know. however it works. It's not the best idea to shirk responsibility. Oh wait. I can do it like this. J is less than I. I'm just trying to make it so when we compute a state like this, we always compute the lesser states beforehand. So for example, we'll start by computing this one, and then we'll compute that's bad. What we want to do is I minus 1. I think that's right. And then in this order, we'll compute like this and then this, which is good. And then we'll compute that, and then that, and then that. I think that's what we want. I don't even know if this works. It might just like not. And then that would suck. Zero. Where is it all zero? Blogs on learning DP and bit masks. It's a good question. I'm not really sure. Well, writing this stuff is kind of intuition. This transition I like struggled with for a very long time beforehand. You just might not have seen that. And in fact, I don't even know if it's correct. So it's kind of just like a random guess. But this is a transition I've seen before, so it's kind of intuitive to me. This isn't exactly bitmask DP. All this is I'm using a bitmask to represent like taking each subset of camels. And then this DP is separate from the bitmask. It just uses the mask kind of to do stuff. I don't understand. Okay, so anything that's equal to 4, fine. Oh wait, this should be a big mask. Whoops. See, I'm still screwing stuff up. It's not perfect. Now we get 10. Now we get -1. And that fails. Fail this too. Nice. Okay, so it's too small. Yeah, this is C right now. I'm kind of dying on it. It's not going that well, honestly. I will rehash the solution if it works, and if it doesn't work, I don't know what I'll do. Just like read the editorial eventually and relay it. Why is this happening? I don't understand what's with this. J equals I minus 1. Oh, J is less than I. Whoops. J plus 1. K is less than I. Why does that still happen? Because now it should be this. Yep. It would be JI, JI, JK, KI. Otherwise, everything's messed up. Because this assumes that the first index is less than or equal to the second one. Alright, now the question is, does it work for this one? And it doesn't. Okay. What's gone wrong here then? What? You don't really need to worry about templates. Like, you can write code just straight out being fine. I don't think that's a necessary thing to learn. It's more like learn to write code, and then you can try out macros that like might help you, but they're absolutely not necessary. Like, I got rid of most of my macros for YouTube. The one thing I do use is this, which basically shorthands long to the phrase LL, which is so useful because long is 9 characters. And you see how often I type it out? Oh wait, this is dumb. Forgot to get rid of that. Still 20. Did I recompile? Why does this happen? Personally, I use long, and then not much else of it is really necessary. Don't understand what's going on. So, let's switcheroo the input. Get this. What? Oh my god, I didn't even use the permutation. What the hell? What am I doing? Okay, this should be PJ. Yes, indeed. Ten. This is the moment of truth. It does work for that. How to be good at graph problems? I mean, practice them. General rule of thumb is practice whatever you want to get good at, but for specific things like specific topics, I don't know, SecondThread has a pretty good video on stuff like DFS and like the tree basics. That's a good one. Other things you can kind of just like, a lot of graph problems come down to algorithms like using DFS or BFS for traversing them, and then we're just going through all the graph, and then later on, either other things are just like the same ad hocness but applied to a graph. It's more about the thinking skills. Okay, general advice, go to Codeforces, go to tags, add the tag that you want, and then sort by difficulty, and binary search on the problem that you can solve within a reasonable amount of time. And then just like start with those and get better. So that's too big, print -1, max is 2 to the n. For each bit mask, just like try it all, man. Take the cost, check if it's like too big, and then if so, it's too big. And that's all you need for the intervals. And then like do DP. Why not? Decent chance it's wrong, but adding DP tags gives problems that can, well, they can be solved by greedy, but they're also solvable by DP, right? So like even if there's a solution, even if there's a solution for them, you can still make it so you can use other solutions. Okay, this is taking way too long. Am I the only solver for C in the virtual standings? Nice. That doesn't matter because D is worth more points. Sad. I spent too much time like doubting my own skills with this interval DP and just like thinking and trying to prove it, and it eventually just worked. Okay, but like to continue my point, like if you have a problem that can be solved by greedy but can also can be also solved by DP, then it's still good practice for DP as long as that part's hard. If you solve it by greedy, you can still try solving it. Interval DP is like, okay, here, let me explain my solution, and then you'll kind of see what I'm talking about. So the first step is this. N is 8, which is like very small. So things like 2 to the n and n factorial are also small. I don't know, problems have been going not the best, but they're well, I have A, B, and C, which is a fine performance, I guess, but it's still like sketchy. How did I get a wrong answer? I don't know, they're fine. Been slower than I wanted to be, but whatever. So 2 to the n and n factorial are small. Specifically, this is 256, and this is like 40,000. 4320, is that what it is? Or is that 7? Yeah, 4320. Okay. So, handwriting OP, as always. But like basically what's happening here is like all intervals can like all intervals can support a certain certain subsets of cows. For example, say you have, or camels, not cows. Stupid use of cow. Right, so say this has, we'll take the first sample, as length 10 and capacity 4. Okay, so now you can essentially, this one can support this subset, this subset, this subset, and this subset, but nothing that contains 4 and anything else. So that's like cool because that lets you like you can see exactly that if you have these two cows or camels, if you have these two camels kind of together, then they have to be at least 10 apart because otherwise the bridge is going to collapse. So for example, we can kind of like list out the possible subsets where a value is 1 if that corresponding camel is in the subset or 0 if not. This is a bit mask, essentially. Right, so, and this assumes that these camels are going to be consecutive, kind of. So, this, for example, these we can get away with these being 0 apart because these don't overload the bridge. However, this one, 4 and 2, does overload the bridge, so these have to be at least 10 apart. This one doesn't. This one doesn't. This one does, so they have to be 10 apart again. And this one also does, so they have to be 10 apart again. And, okay, now, this is only one bridge, but it turns out that we can kind of just like, okay, not it turns out, that's bad, but all the bridges are kind of the same, they're kind of like independent of each other. Like, it's enough to just like, yeah, like the bridges don't affect each other. So, if we solve for all bridges independently and then combine their answers at the end, that just works. So if we, for example, have another bridge that says that these actually have to be 12 apart, then this kind of overrides this constraint because this is a higher distance. And in a similar fashion for like all of the masks, like the final distance it has to be apart, taking all the bridges into account, is just the maximum of the distances over all bridges for that mask. Now this is like a useful metric. This is a useful value because we can do some stuff with it. But like specifically, what can we do with it? This graphic doesn't make sense. What we're basically saying is, over all bridges, this subset of camels, Jesus. This subset of camels, I think my brain is like defaulting to cows in this deteriorated mental state I'm in because I'm so used to Yusuke. So if these three camels are going to be together somehow, then the distance between the first and the last camel has to be x. Yeah, just Yusuke things. So, cows, camels, cows. They even sound the same. Like, no, it's just like an M. Anyway, so this kind of says the same thing. If these two camels are ever going to be together, then they have to be at least some other x distance apart from each other. And the same for here. If we have the first and the third cow kind of consecutive, they have to be some other x distance apart, otherwise they're going to overload some bridge. And the way to find out like if it's going to overload a bridge is just to take the maximum of like all of these values over all of the bridges for this mask. Like intuitively, like, no, I don't know if it's intuitive. But for each bridge, you basically ask, can it support this subset of camels? And if so, then they can be 0 apart. They can just be like on top of each other because you don't care. But if not, then they have to be the length of that bridge apart. And so over all bridges, the cost of, like, the required distance for this subset is the length, the highest length of the bridge that can't support them. That's a different way of putting it. It's still equivalent though. So now we have this value. We have this value for all bridges. So we have 2 to the n times m. This takes 2 to the n times m to compute because we have 2 to the n bit masks and we have to go through every bridge every time. But this is like what is it? Like 25,600,000? That's not that bad. So this part's fine. And now we'll just assume we have these values for all bit masks. And this goes for over all bridges and over all subsets of camels. I said it that time, camels. Okay, now we also note that n factorial is small. And so the problem with this is that it only like works for consecutive stuff. But if these camels are like arranged whatever which way, then it's not really going to help us. Because we get these like weird constraints. So let's instead fix some order of the camels we're working with. For example, we're going to say the third one is first, then we have 1, and then 2. That is bothering me a lot. It's the fact that this gets cut off, but like not at the place where it looks like because the scroll bar is there. Okay. But yeah, so say we have this ordering. Then we can kind of create this like series of constraints. How wide must this interval be between 3 and 1? Well, we already know that the distance that this subset of camels must be. It's the mask formed by the camels on this interval, which happens to be this. And so we can use these values to now say that this interval must be of length at least, in this case, 0. And this interval must be of length, I'm going to use the same color actually. And this interval must have length at least the value of its mask, which is this mask, and so that's 10. We can do this for all intervals. So this is 0. How do I do this? This is 0. All of these individual ones are 0. It's not a good way to draw this. This is 0. And the whole interval, which is the whole mask, is 10. So now, this is like cool, but we can't just use this because let's take some other example to illustrate this. We have 1, 2, and 3. Wait, what is the other example? Is this impossible? No, okay. What we can say is, let's say we have 4 camels, all of them with weight like 4. Right, so this interval is too big, and this interval is also too big. But we can say that like these camels must all be 10 apart, assuming we have this as a bridge. But like the sub-intervals are also too big, so we actually have that this has to be like 20 apart. And in general, somehow we have to use the answers for the sub-intervals to also build up to the big one. And we can do this with like dynamic programming, kind of, where we let dp of I and j, or actually let's call them L and R, be the By an interval, do you mean some set of camels? Well, kind of. Yes. Like, in the sense, we fix this order. We fix the ordering of camels to be this because we don't have that many orderings. And then an interval of camels is going to be some like it's going to be it'll be some subset, but it'll also be an interval given this specific ordering. So it's an interval like within our ordering. So then sticking to this ordering, we're going to find the like required length for this ordering, and then we'll take the minimum over all possible orderings. So dp of L and R is the required length of the interval L to R. And the transition is essentially that if we have some interval here, then we'll pick some split point, and then the answer is like it could possibly be the cost of making these two intervals, because these two intervals must be separate from each other, but they're also like joined at a point. And what I mean is like if these must be some x distance apart and these must be some y distance apart, then the two endpoints must be x plus y distance apart. So first of all, doing a split point is enough. If we have multiple split points, then like one of these will be contained in the smaller interval, so we can kind of ignore that. And a split point is the only required transition because like if we have some other weird thing, if we have some two intervals that kind of overlap, which means that the transition won't work, these two intervals won't affect each other anyway, because this is some element inside this interval which could possibly just be like at the end. So these two intervals kind of don't care about each other. And yeah, therefore it's like chill. So we can just use the transition of putting a split point. Well, what split point do we use? It's like not clear, so we have to try all of them. And it's the maximum over all k of dp of lk plus dp of k and r. And that's the final transition. Basically, it's enough to pick some split point and then take the maximum over all split points of the two intervals. Last part again. Well, okay, basically the idea, the reasoning behind like not needing, the reasoning behind this transition being enough is like, okay, if you have multiple split points, then like considering the case with only one split point, if you in fact need two split points, then all of this is in one interval. So the case of having this as a split point is already considered like when you solve for this interval. So if you have multiple, you can kind of split it into the case where you only have one split point by noticing that the other split points are just like on certain sides. So you would have already considered them already. And if two intervals intersect, then they just like, they don't affect each other. Yeah, it's redundant. And if two intervals intersect, meaning the split point just like wouldn't work, like they don't affect each other. Like just look at this. This has no constraint on this. This has no constraint on this, and this has no constraint on this. And if it does, then we would solve for it like in a different place. But it doesn't. So these two intervals are just totally independent of each other, and therefore there's no reason to consider them in a transition. Because ultimately we would consider both of these individually. Yeah, basically I think it just takes care of everything. That's what I'm saying. And also, there's one final thing. We initialize all the dp values to like these costs. We initialize the values to these costs that we derive by the bit masks. And then the DP values are the maximum of this and the initial cost. Because, like, you also have to consider the initial cost. So anyway, then once you compute this, which is very simple, then the answer is the DP of 0 indexing 0 and n minus 1. Yeah, the stream is going on for a long time. It'll probably end soon. Once I finish with this contest, it'll be over. So we DP of 0 and n minus 1. Because, like, that's the full interval. That's what we want. And then this is the answer for a single ordering. You try all possible orderings. My implementation of this is using next permutation. It's very cool. You can check out the code if you want. I'm not sure about other other languages if they have something like this. But there's an algorithm for generating all permutations. Or you can do DFS or like whatever. There are a lot of ways. So the answer is DP 0 and minus 1. And over all n factorial orderings, you do the DP, which is in total of n cubed. And then you add this to 2 to the n times m. Okay, let's see. That was really long. That was so long. Don't think I have it in me to solve the other problems at this point. Okay, I'm gonna leave it at this. Even though there's 5 minutes left, I'm just like not gonna get anywhere else. So I might just, I guess, end the stream here or something. Check out. I can't imagine I did that well because like there's a lot. Like people could probably solve D. I can check out my place though. It's 1,000 with 79 minute penalty. Alright, that's not the best. Eventually. Alright, we'll finish with that, I guess, the hacker rank thing. Where is this? Is this, just here? Sure, whatever. I'll do it over Discord. Like, it doesn't have to be a stream. I just explain it in text. This is enough for one day, to be honest. Look at all this. Scribbles. Can do it possibly some other time. Or just over Discord or something. Alright, this is enough. Goodbye all. Hope you enjoyed. It's kind of scuffed near the end, but there was some stuff in there.